All right, so question 11 says we're going to pull on something with a magnitude of 600 newtons and 500 newtons. The 600 newton is going to be pulling at a 70-degree angle. The 500 newtons is pulling at a negative 35-degree angle with the positive x-axis. So we should be able to figure out the direction and the magnitude that the result of those forces is going to be. All right. So a picture is going to help us out here. So one picture, what it would look like in person, is here's your object, and one force is pulling this hard at this angle, and then another object is pulling this hard at this angle. And the more realistic you can make that look, the more your answer should make sense. So if this is the 70, 600 newtons, this is 500, negative 35, then the angle is going to be, I don't know, somewhere in here, 20, 30 degrees. I can see that. And if I'm pulling on it this hard and this hard, then, I don't know, to the right, I'm pulling on it more than 600 total. And it looks like overall I'm pulling it more up than I'm pulling it down. So I know my vertical component should be positive. I can get all that from the picture. Now, that being said, this is what it would look like in real life. I still don't think that that's the kind of picture you should draw with vectors. I think what you should draw is you should pick one of these to be vector 1, and it does not matter. Sketch it. And then I think it's better to sketch your second vector to start at the end of your first vector. So, starting at the end of my first vector, I'm going to now sketch and again, it still makes sense to try to get this right, or to try to get accurate. I'm calling this 600. This should be less because it's only 500. This should be about a 73 angle. This should be about a negative 35. Okay, now I can see the result of these. If nothing pulled on it, my object would stay here. If I only had this first force, it would stop here. But since I've got the second force, it's going to stop here. So this red line is what's actually happening. And so when I draw this as a vector, it's the result of those other two vectors, which is why it gets its name resultant vector. So what it amounts to is this first vector is pulling it some to the right, and this vector is pulling it some to the right. So if I knew how much this is pulling it to the right, and I knew how much this is pulling it to the right, I could add those up, and I would know how much this one's getting pulled to the right. So let's do that part first. Got two vectors here. I'm going to make this green one be my first one. So it's going to be going, how much is going to the right would be this length, which would be cosine of 70 times 600. Do a circular equation and see that length if you need to. Okay, and then I'm going to make my second vector purple. How much is going to the right would be 500 cosine of negative 35. Okay, do a full circular equation to get that length if you need to. So we're going to add those up. So this is greatly oversimplified. If this is pulling it to the right 3 newtons, and this is pulling it to the right 4 newtons, then the result of that is it's going to pull to the right 7 newtons. You want to add those pieces together. So 600 cosine of 70 plus 500 cosine of 35. Notice these are only cosines I know because they're dealing with the horizontal component. And then the same idea with the up and down. This one's pulling it up a bunch, this is pulling it down some. By adding those together to figure out what's ending in happening. So this would be 600 sine of 70 this would be 500 sine of negative 35. Adding them together, 600 sine of 70 plus 500 sine of negative 35. So I'm going to type all this in my calculator once, carefully, store it as x. Type all this in my calculator carefully, store this as y. And then I have two sides of the right triangle, so I can answer the stuff that they want. With some right triangle stuff. So there's a lot of patterns to these questions that I hope that you see. I don't point them out too much because I don't want you to try to just make shortcuts to get the answer. But these are degrees, so make sure your calculator is in degree mode. There's x. Y should be the exact same thing except for signs. And I didn't just assume that, I worked it out. And I can see that that's what happened. So now, if I want to know the magnitude of these forces, it's going to be the hypotenuse of a right triangle when I know two of three sides. I can do the square root of x squared plus y squared. And since I have it typed in my stored in my calculator this way, type it in this way, which is where you should get an answer of 674.321 meters. Okay, and then if I want to know the angle that it makes, so in other words, I want to know the angle of a right triangle, and I know opposite and adjacent. That would be inverse tangent of opposite over adjacent. So having this x and y stored pays off for me here too. And with this, sometimes we need to add 180, sometimes we don't. So based on the range of inverse tangent, negative pi over 2 to positive pi over 2, or negative 90 to positive 90. If your angle is in quadrant 1, you won't want to add anything to it. If you don't remember those rules about inverse tangent, you just look at your this is going right up. Quadrant 1, 24 is in quadrant 1, adding 180 would definitely send it wrong direction. Questions you want to ask about that rule of stuff?